What up, athletes? Whoop, whoop. All right, let me just move stuff around here. Today is 1.5. I will evaluate the absolute value of expressions. Take a minute, pause this, and identify the letter which this is talking about. Okay. I'm assuming you've done all this. So negative 0.7, see 0, between 0 and negative 1, that's D. 2.4, we'll see that's close to 2.5, which is halfway between 2 and 3. That's closest to F. Square root of 8, you may be wondering, how do we do that? Well, the square root of 9 is a perfect square, and it's 3, right? Square root of 4 is right below it, and it's a perfect square at 2. So is 8 closer to 9 or 4? Well, it's clearly closer to 9. So we know we're going to be closer to 3 with the answer, which is G. Then 2 1/4, again, that's between 2 and 3. The only one left is E. Boom. Okay, we're going to go take a look at some vocab. The absolute value, take a minute, pause this. It's the distance a number is from 0 on the number line. And basically it comes down to this, guys. We always measure distance positively. You never say I drove -5 miles or I ran -2 miles. It's always positive. I ran 2.5 miles. I drove 152 miles. It's always positive. So absolute value is the measure of distance from 0. It's a distance measure, which again is always positive. So if it's positive, it stays positive. If it's negative, it becomes negative. And the absolute value sign, why isn't it drawing? That's weird. Draw. There we go. This is the absolute value sign. It looks like 2 straight up and down bars. Be careful though, because if you're ever taking like the absolute value of 11, you want to make sure that you draw those bars bigger than the 11 so it doesn't look like 1,111, right? Okay. Let's go to the next slide. Fill in that box you see that says absolute value of variables. I'm going to zoom in into it, or not zoom in, but get it loaded up for you. And you're just filling in the symbols and the examples. So the symbol says for any real number x, the absolute value of x equals x, if x is greater than or equal to 0. Okay? And absolute value of x equals negative x, if x is less than 0. So in other words, if x equals 12, then the absolute value of x is 12. It keeps a positive number positive. But if x is -7, then it's going to make it a positive, the opposite, right? The negative of that, which is negative makes positive, and that becomes positive 7. Makes everything positive. Just know that. The absolute value makes everything positive. Okay, so now we're going to head back to our regularly scheduled program. You should have that filled in. And I want to talk to you. Number 1, right here. Those bars, that is the absolute value sign. Okay? Secondly, let's do just a little example. What's the absolute value of 11? It equals 11. What's the absolute value of -11? It equals still positive 11. All right, and for these, I want you to make a habit of filling in unknowns with a parenthesis. So we're going to have absolute, if m equals -6, then it's going to be absolute value of -6. See how I did those parentheses inside the absolute value? And what's the absolute value of -6? Well, that's just positive 6. What about if the negative's on the outside? How does that affect it? Well, let's find out. I'm going to plug n in, so it's going to equal the negative absolute value of n is 4. What's the absolute value? It's 4. However, that negative's on the outside, so the absolute value can't change it. So this becomes -4. This is a way of forcing a negative number. Again, let's look at it on the inside, see how it differs. So I'm going to have the absolute value of negative, and then instead of negative p, what's my p-value is 2, which is really just the absolute value of -2. What's the absolute value of -2? It equals 2. It's a positive 2. Should be squaring my answers, right? And now let's try it one with both. So we have negative absolute value of negative, and in parentheses our m is -6. What do 2 negatives make? Now, we can combine these 2 negatives on the inside because they're inside the absolute value sign. I cannot combine with anything outside the absolute value sign. So these two negatives make a positive, so this becomes the negative absolute value of 6, which is just going to be absolute value of 6 is 6, so this is negative 6. Awesome. Pause if you need to. Let's get rolling. Down here, let's read this together. The accuracy of a meat thermometer is the positive difference between the temperature reading on the thermometer T. By the way, we said positive difference. A difference is a subtraction problem. To force a subtraction problem to be positive, we're going to need absolute value signs. And the actual temperature of the meat, boom. Which expressions are and are not equivalent to the accuracy of the meat thermometer? Well, let's walk it through. Let's just pick a value for m. Let's call it 2, and t we'll call 5. So I'll say m equals 2, t equals 5, just for our testing purposes. Well, we got the absolute value of 2 minus 5, which equals the absolute value of negative 3, which equals 3. Ooh, that's positive. Let's flip sides, make sure it works the opposite direction. What if we have absolute value of 5 minus 2? That equals the absolute value of 3, which is just positive 3. So yes, number 1, this does represent the difference, so this is the difference. And number 2, and I always put this in parentheses so we know it's not an 11, it's an absolute value sign. The absolute value forces a positive. I'm just going to draw a positive symbol. Let's look right here. Same deal. What if m is 2? So we have absolute 2 minus the absolute value of 5 for t. Well, absolute 2 is 2 and absolute 5 is 5, so this just becomes 2 minus 5, which is negative 3. We don't want a negative. We want the positive difference. Okay? So because of this, what we can say is it doesn't work because it will be negative for absolute value of m is less than the absolute value of t. Whenever this absolute value of m is less than that value t, boom, it doesn't work. It gives us a negative answer. What about if we do the same thing as a, but just switch the order? Does order actually matter if we're taking an absolute value? Normally it does in subtraction, right? It changes everything, changes the sign, but let's try this out. If t is 5, I'll have 5 minus 2 absolute value, which equals absolute value of 3, which equals 3. Okay, so that works. We knew switching the order would work. Let's try it the other way. Absolute value of 2 minus 5 is going to equal absolute value of negative 3, which is positive 3. Again, same thing. This is the difference. And the absolute value forces a positive. I bet you guys can guess a similar thing's going to happen here. Let's set it up. So we've got absolute value of t is 5. Absolute value of 5 minus the absolute value of 2. Which ends up being 5 minus 2 is 3. What if we switch that order? Absolute value 2 minus absolute value 5. Now we have another 2 minus 5, which is negative 3. So this one is very similar to b, except for one thing. It will be negative for absolute t being less than m this time, absolute m. Okay? Take a minute, pause this, write it down. We're going to talk about how to evaluate some series expressions here. Okay? So look right here. I'm assuming we have, I should take a drink so you can pause it. Write stuff down. Boom. Let's roll. Anytime I see variables, I'm just going to put a set of parentheses. So I'm going to have absolute value of negative 2, parenthesis, plus 5 times parenthesis, absolute value. Now the first one should be x, which is 6. Second one is y, which is negative 3. Over here I have y, which is negative 3. Let's see, I have a negative times a negative, which is a positive. 2 times 6 is 12. 12 times 3 is 36. So I'm going to have this equals absolute value of 36. And then plus, maybe, what's 5 times negative 3? Well, that should be negative 15. So that's going to be plus negative 15. What does a positive negative make? It makes a negative. So 36 minus 15 is 21. So this equals the absolute value of 21, which equals 21. Well, why don't you pause it, guys? Try B and C, and we'll get back to it. Okay. Absolute value of 4 parenthesis minus 3 parenthesis. It's like the opposite of this one, right? And y is negative 2, x is 2, y is negative 2. So this is going to be the absolute value of negative 8. And then I've got a negative. Negative makes positive. 3 times 2 is 6. 6 times 2 is 12. I've got a battle between the negatives and the positives. The positives are bigger. They win. So I'm going to get 12 minus 8 is 4. Positive 4. What's the absolute value of positive 4? It's 4. Boom. Last but not least. Now, we really want to treat absolute value signs as parentheses, except we have to do the math operations first inside of them to turn it into regular parentheses. Watch what I mean. So this 2 next to the absolute value sign actually means 2 times, just like a number next to a parentheses multiply, right? So we have 2 times the absolute value of 6, parentheses minus 20, absolute value minus 4. Plug in 3, and we get 6 times 3 is 18. What's 18 minus 20? Well, that's negative 2. So this is going to be 2 times the absolute value of negative 2 minus 4. We have to evaluate this first. We don't multiply these and get negative 4, because watch, what's the absolute value of negative 2? It's positive 2. So I end up with 2 times 2, which is just 4. What's 4 minus 4? It's 0. Boom. Right, again, pause this, look at it. Let's go to the back side. I'm going to tell you the same thing. Pause it. Take a minute, see if you can work these out, and then we'll talk about them. Okay? So for D, I've got 23 minus absolute value of 3 plus 4 times parentheses. So I'm going to plug in a 2. That's 8. 3 plus 8 is 11. So I get 23 minus the absolute value of 11. Again, make those absolute value signs big so we don't mistake it. And that's going to be 23 minus 11, which equals 12. Boom. For E, let's write it down. 2, I'm leaving myself a little room, so I need extra room for F. 2 parentheses plus 4, or absolute value. I almost called it 14. See, I did that even. Absolute value of 4 parentheses minus 2, absolute value sign. In that parenthesis goes, let's see, this one is 2x, so that should be 2. This is 4y, that's going to be negative 3. So I can do these. Watch this. 2 times 2 is 4, so I'm going to have 4 plus the absolute value. In here I have 4 times negative 3 is negative 12. Negative 12 minus 2 is negative 14. What's the absolute value of negative 14? It is 4 plus positive 14. Notice we didn't combine those signs because an absolute value has to be evaluated first, which equals 18. Oosh. And last but not least, this one looks complicated, but really isn't. It's just parenthesis for A times B minus absolute value sign 3 times B plus 4 times our A value, right? Plus 2 times our B value. So let's write that in. A is 7, B is 5. 3 times B is 5. 4 times A is 7. And 2 times B is 5. Lots of multiplication right in the first step. So 7 times 5 is 35 minus the absolute value of 15 plus 28 plus 10. 15 plus 28, 38, 43, right? So I have, what's the absolute value of 43? It's just 43. So 35 minus 43 plus 10. I'm going to go ahead and add 10 to 35 because order doesn't really matter here. So I'm going to get 45 minus 43, which equals 2. Boom. All right, that's it. That's the math lesson. With that said, let's get into these absolute value signs and crush it. Peace out.